Hi guys, welcome to Piece of Code and welcome to this video. In this video, we are going to discuss about the summary of chapter number 3, and in chapter number 3 we have learnt about the core Java APIs, which included string builders, date and time API, then strings, then arrays, array lists, and so much, right? We discuss a lot much in this particular chapter. We're going to see a small summary on this chapter, the main takeaways, and we're going to discuss some expected questions from this particular chapter. Let us move on. So these are some main takeaways from this particular chapter here that you need to keep in your mind while appearing for the exam. The first one is be able to determine the output of code using a string, right? So know the rules for concatenating strings and how we use common string methods, like for example to uppercase to lowercase dot substring, and always remember that they are immutable. So basically they return a new instance of the string, right? I hope that makes sense. Be able to determine the output of code using string builder, and you must remember that string builders are mutable. So whatever methods you're going to apply on this particular string builder instance, it's going to change the same string builder instance itself. Understand the difference between equals to and equals. Very, very important to understand, and if you have some doubts between these two things, I have a separate video. There's a separate episode on the equality of strings and string builders. You can go and watch that. And always remember that the equals method compares the values and the double equals to compares references, and that should be a hint actually, right? Be able to determine the output of code using arrays, right? So know how to declare and instantiate one-dimensional and multi-dimensional arrays. There are multiple ways we can declare arrays. Remember that. Don't get confused in that. And be able to access each element and know what an index out of bounds exception is. Very, very important to understand. Then coming to the array lists, right? Know that array lists can increase in size. It's a dynamic array, right? And identify different ways of declaring and instantiating an array list, correct? Identify correct output for array list methods. There are a lot of array list methods, like for example dot set, then dot add. A lot of methods are there, right? So basically you need to understand what each of these methods does. Recognize invalid use of date and times. Now remember, there are a couple of things that date and times does. For example, there is a date time exception. You have to be wary of that. And there is another type of exception we saw which happens with date and times while formatting and stuff, is the unsupported temporal type. And there is also a date time format exception, right? So these are some common exceptions which occurs with date and time. So you need to remember when and how this kind of exception occurs and what is the reasons for that. And we have discussed this in detail in my dates and times chapter. So I hope it makes sense. Alright, so these are all the main takeaways of this particular chapter, guys. Let us move on to some questions that may come from this particular chapter. Alright, let's go. So let us talk about this question. What is the output of the following code? So we have a class fish. So you can just pause the video and can answer the question by yourself, okay? Then we have a int numfish over here. That's an integer, and then we do this stuff, and then we do this, and just whatever it's over here. So what will be the output of this particular question? What will be the answer? The simple thing is that if you take a look at this line number 5, it's not going to compile. Why? The question is actually checking to see if you are paying attention to the types. Now numfish that you see is an int, I've already told you, and 1 is an int over here, right? So what happens over here? So we use numeric addition and get 5, so it will be 5, right? But the thing is, we can't store an integer in a string variable. Now supposing, right, line 5 is this particular line 5, it says another fish equals to numfish plus 1 plus a pair of quotes, double quotations. Then what it becomes in this case? In this case it becomes a string. So now there will be no compilation issue. But if this is not the case and we see it over here that it's just trying to store an integer in a string in this case and it's not possible, so the answer will be G, which says the code doesn't compile. I hope you guys understood the question. right? It's just a matter of different data types. Now let us look at this question. It's a little bit tricky question to understand. It says which of the following output of this code, right? So if you see here at line number 3, first of all, the code compiles really fine. First of all, you need to check if the code is compiling or not, but in this case it is completely fine. The code, there is no issues with the code, right? So F is out of the question itself. So string S equals to hello. So when we create a string like this, what happens in the string pool? Hello is created, right? That is fine. That is understandable. When we say string t equals to new string s, then a new instance of string value, string is created with hello as its value. So both are different. Both are different. Now in line number 5, when we do hello dot equals s, now in this case it compares the equality, right? Like if both the values are equal or not, so it is true. So 1 will be one of the outputs. Here over here, what we are doing, we are not doing equality of the values, but instead this operator compares the reference equality, and if you see both t and s have different references, so now it will be false, so this will not get printed. This will print true because we are using the equals method. That's gonna return you with 3. And over here, now here it becomes a little bit trickier. This is a value which is hello, right? And it is being constructed at runtime, and there we have a s which is already present in the string pool. Now when we use a double equals to, in this case it will return true. Actually it will be 4. Why? Because this one is already in the string pool, and when you say hello over here, at the runtime it is said, okay, there is a string named hello in the string pool, so it is the same value as that particular string. It is the same reference. Both are pointing to the same reference in the string pool. That is why this is gonna return true in this case. But this is not gonna return true, and it will return false because t is already been constructed as a new string object. So it is not present in the string pool at all. Whatever you compare with this particular t, which is a new reference with the double equals to operator, it's gonna be different at all times. That is why in this case it will return false. So what are the output? 1, 3 and 4. And if I see the options, that is 1, 3 is C and 4. A, C and D will be the options. Now this was a little bit trickier, I understand, but it requires good number of practice to get this thing in your mind. Alright, let us move on to the next question. Which are true statements, right? And you just have to read through it. Now by looking at this particular question, I'm gonna say B and then C and E, because see, immutable means the state of an object cannot change once it's created. So immutable objects can be garbage collected just like mutable objects, right? String is immutable. String builder can be mutated with methods like append and delete and stuff. Although string buffer isn't on the exam, you should know that it is, it's just it's kind of an older question. It's not in the exam, but still you should know that it kind of is the same like string builder, only it is thread safe. So if you see the options over here, immutable object cannot be modified, which is true. And regarding string buffer is also mutable because it's the same thing as a string builder, just only it is thread safe. So B, C and D are the answers. I hope that is enough explanation for this question. Talking about question number 4, right? Now it says, what is the result of the following code? It's a very easy question, guys. And the very funny thing is that it uses method chaining. And if you can figure out what it is going on over here, then you will see that the answer in this case is B. A, B, B, A, C, 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 A. Now string builder is a mutable object, and what we do, we first of all create an empty string builder, then we just do a append AAA, then insert BB at the first, so it will be BB AAA, right? What we are doing after that, sorry, not BB AA, we are inserting at position number 1, so it was A, so at position number 1 we insert BB, so it will be A, B, B, A. So we got about this, and then we insert at position number 4 we get CCC, so 0, 1, 2, 3 and 4. So at position number 4 we insert CCC. So 4 will be over here between these two things, right? Because that will be the position number 4. So it will be A, B, B, A, then insert CCC and then A. So this will be the final output. So as this is mutable, it will just mutate or change the same string builder instance, so you don't have to worry about immutability or storing it in a separate string builder object. So this will be the particular answer in this case. I hope that makes sense. Question number 5. It's also a very easy question, guys, and the question is actually trying to distract you into paying attention to logical equality versus object reference equality. The same kind of question we just did like in question number 2 or something, right? So it is hoping you will miss the fact that line number 4 does not compile, right? If you see this line doesn't compile. Why? Because it's a string and a string builder. Obviously, we're trying to compare two different types of objects, which is not possible. That's great. So I hope in this case the answer will be F without any questions. It's a very simple question, guys. Alright, let's move on to question number 6. It's kind of a little bit tricky, but it's also a very simple question. First of all, a string is immutable. Calling concat returns a new string. I should hope you know that. So what happens in this case? It returns, so basically, calling concat, what happens? Returns a new string, but does not change the original, obviously. A string builder is mutable. Calling append adds the character to the existing character sequence, along with returning a reference to the same object. So it changes the same object. So in this case, what do you think will be the answer? In this case, the answer will be B, roar and roar. So I've already given you explanations, because if you see, if you do a roar1.contact, it's a string. It's not going to do anything, right? Because it's going to return you a new string and you're not changing the original string. And then you do a roar2.append. So you are changing the same string builder object and it is a mutable, right? And I hope that is enough explanation. That's why it's B. Talking about question number 7, it's a very simple question actually, guys. And in this case, if you see this question, the answers will be B, D and E. Why? Let us understand this thing. Length is simply a count of number of characters in the string, right? So when we do a dot length, we just get 1, 2, 3, 4, 5, 6 as that, right? In this case, there are 6 characters that we get 6. Character at returns the character at that index. So I hope you know what is the character, which is D in this case. Remember that indexes are 0 based, which means that index 3 corresponds to D and index 6 corresponds to 1 past the end of the array. Right? So basically what happens after that? When we say at character dot character at 6, so there is 0, 1, 2, 3, 4, 5, 6, which is past the array, right? As I've told you. And then what will happen? An string index out of bounds exception will be thrown. So an exception is thrown is the particular output in this case. So 5D and exception. I hope that is clear. Talking about question number 8, guys. It's also a very simple question. Answers in this case will be A, D and E. Why? Now remember that substring has two forms. The first takes the index to start with and the index to stop immediately before. So if we say substring 1, 4, then it will extract the substring from 1 to 3, close brackets. So the last digit is actually omitted or it is ignored. So that's how the first form works. The second just takes the index to start with and goes to the end of the string. So if we say substring 1, then what happens is basically it will go from 1, the first index character, to the end of the string. I hope that is clear. And remember that indexes are 0 based. So the first call starts at index 1 and goes till index 2, since it needs to stop before index 3. The second call starts at index 7 and ends at the same place because it's 7 and 7, right? So it's the same character, and it results in an empty string, right? That's why it prints out a blank line, right? That's why it's one of the outputs. Then the final call starts at index 7 and goes till the end of the string. So basically that's why it is 7 and 8, right? So I hope that makes sense. It's a very easy question and you just had to remember the different signatures of the substring method. Now talking about question number 9, guys, and the question is actually trying to see if you know that strings objects are immutable. And actually if you have a look at this particular chapter, one of the very most important things that this chapter tries to test you is on the immutability concept of strings. If you are very much familiar with that, then you can answer like most of the questions of this chapter, but whatever. Line number 4, which is per, I don't know, this is capital PURR. So basically what happens is that it returns the per, but the thing is the result is ignored and not stored in S, because it's not gonna mutate the original string. It's an immutable object. So so whatever we are doing over here, it's basically completely ignoring everything, because we are not storing it in the same string S. We're not reassigning the value. So basically what is happening over here, it's all of the operations over here are just useless. It's gonna say that. That is why when we do S dot length over here, we get 8. Answer is C. Why? Because at the 7th line we do a concatenation with 2. So if it is per 2, 1, 2, 3, 4, 5, 6, 7, and okay, there is a space. So it will be like per a space then 2. So it will be 8. All of these operations are just useless. So sometimes when you see this kind of question, it actually tries to distract you from the fact that strings are immutable. I hope that is clear. Talking about question number 10, guys, what is the result of the following code? And if you see this question, the answer in this case is F, which is equals. Now let us talk about this thing. It's a little bit difficult to understand. Let's try to tap it down and make it easier. A plus equals to 2 expands to what? A equals to A plus 2. A string concatenated with any other type gives a string. So lines 14, 15 and 16 all append to this A, right? Giving the result to what? The result will be 2C false. The if statement on line number 18 that you see on the screen returns false because the values of two string objects are the same using object equality. Right? What I'm trying to say. Just let me repeat it. The if statement on line number 17, you can see that we are using the double equals to in this case. That's why it is false over there. Right? Because both are the same different objects. Even though the values are same, you can say they are different objects. But when it comes to 18, we are using the equals method, and when we use the equals method, we just compare the values. So that's why the output is equals. So yeah, you have to be very, very careful when we deal with immutability and the equality of strings. I hope that is pretty much of clear in this case. Talking about question number 11, guys. In this particular case, the answer will be E, that an exception will be thrown. Why an exception will be thrown? Now line number 6 adds 1 to the total because substring includes the starting index but not the ending index, right? Basically, I hope you can understand that in the substring, if you say 1 to 2, it will go from 1 to 1. Right? So what happens in this case? Line number 6, it adds what? It adds 1 because it extracts only one character, 1 to 1. Right? Now line number 7 adds 0, obviously, because it's an empty string, because it's 6 and 6. And line number 8 is actually the problem over here. Why line number 8 is a problem? Because Java does not allow the indexes to be specified in reverse order and throws a string index out of bounds exception. This is not possible over here. So that's why there's an exception. I hope this is clear, guys. Talking about question number 12, guys. And at first, what we do, we delete the characters at index 2. If you see, what we are doing, we are deleting the characters at index number 2. Right? That is cool. Now, so what we are doing? So we are doing from index number 2 until the character 1 before index number 8, because as I've already told you that when we are dealing with indexes, the starting and the ending index, the starting index is included, which is 2, but we are going to delete till 7, the 7th index, not till 8. I hope that makes sense. So at this point, 0, 1, 8, 9 is in numbers. 0, 1, 8, 9. Because we are deleting from 2 to 7, right? Then we get 0, 1, 8, 9 is in the numbers. The following line uses method chaining, right? So this particular following line over here, it uses what? It uses method chaining. It appends the dash to the end of the character sequence, resulting in 0189 hyphen, and then inserts a plus sign at index number 2. So it becomes 01 plus 89. So what is the answer in this case? 01 plus 89. So it also is based on the fact that string builder is a mutable object, right? So we don't have to reassign the values again in this case. Let us talk about the next question, question number 13. You can in any question, if you wanna like pause and do it on your own, you can just do it on your own. That's completely fine. Now this a little bit of tricky question, right guys, in this case, because you can try it on your own, but the thing is, in this case the answer will be F. The code doesn't compile, and the first line doesn't compile because you cannot assign a string to a string builder. Now you may get confused to the fact that if you can do this string s equals to bubble, why can't we do string builder s1 equals to bubble? Now you can get confused in both of these lines, but this is possible and this is not. So whenever you see this kind of stuff, you just say it's completely false. So that's why the code doesn't compile in this case. I hope that is understandable. Going to question number 14. The answer in this case is A and C. A and C. The reverse method, right, is the easiest way of reversing the characters in the string builder. Therefore, option A is correct, right? Option B is a nice distraction, nice little distraction. It does in fact return J. I mean, what it is, AVAJ. That's the reverse of the string, right? However, substring returns a string which is not stored anywhere. Remember that. And option C uses method chaining. First, it creates the value Java VA J dollar. I think that is correct, right? J A V A V A then J dollar. Okay, that is fine. Then what it does, finally it removes it creates the value this thing, and then what it does, it removes the first three characters 0, 1 and 2 because last index is kind of omitted. First three characters resulting in what? Resulting in A V A J dollar. The first three characters are just removed. Finally it removes the last character resulting in A V A J, which is the reverse. So that is true. Option D throws an exception because you cannot delete the character after the last index, right? And remember that delete character at uses indexes that are 0 based and length counts starting with 1. So basically length returns you the actual length of the string, not 0 based index or the last index. I hope that makes sense. So the answers are A and C in this case. Let us move on to the next question, guys, and talk about question number 5 in this case. So in this case, question number 5 is related to which of these array declarations is not legal, and it is very easy question, guys, and it's pretty simple. It's C, E and F, because if you see this is not legal. Sorry, it's not legal. Sorry. In this case, if you see here, there should be what? There should be the data type, but here we are mentioning something else. We are mentioning this variable name, which is not possible. We should have the same number of brackets over here and here. So if you are creating a multi-dimensional array, it's a 2D array over here, we should mention 2 pair of brackets over here. And we cannot use the keyword Java over here. That is not possible, right? You cannot use it like this. So I hope that is fine, and this is the illegal declarations in this case. And other things are fine because int scores this much is new int, that is fine. We can because column size is kind of not mandatory. Object type arrays are perfectly possible, and in this case it's a 3D array, and this is a dates array, which is completely fine. We are creating an array of date objects, so it is completely fine. So C, E and F are the illegal type of declarations. Alright, let us move on to the next question. So let us talk about this question. Which of these compile when replacing line number 8, right? So if we replace something with this particular line, what will compile? So it's a very easy question and the answer is C. Why? Because arrays define a property called length. It is not a method. So parentheses are not allowed. I hope that is clear. So it's C. Question number 17. It's very easy question. Which of these compile when replacing line number 8? It's just the same thing as the last question, but if you remember, in array list is a class, so it has methods, right? So the answer will be, in this case, will be F, because there is a size method in the array list class. There is no property over here, so others will not work. Now talking about 18, it's also a very easy question, and it's just some true statements about array and array lists. And in this case, I'm going to go with A, C, D and E, because array has a fixed size, you cannot increase it. Array allows multiple dimensions. Yes, it is true. Array is ordered and an array list is also ordered, right? Array is immutable. It's not true actually. An array list is immutable. It's also not true. And an array list has a fixed size. It's also not true because it's a dynamic array, right? So let's go on to the next question. Question number 19. Which of the following statements are true? Actually, it's also a very easy question. So in this case, it's B and C, because an array does not override the equals method, so uses object equality, right? Array list does override the equals method and defines it as the same elements in the same order. The compiler does not know when an index is out of bounds and thus can't give you a compiler error. So the code will throw an exception at runtime. So it's how it is, right? Question number 20. When we talk about question number 20, the answer in this case, if you see what is the result of the following statements, the answer in this case will be D, compiler error on line number 9. Because you see, I've already told you in the chapter that array lists are homogeneous, right? So if you are declaring a list of type string, you can only add string types, cannot add an integer type, so it's not going to work in this case. So compiler error on line number 9. Talking about question number 21. What is the result of the following statements? And it's kind of an output question. Now in this case, the answer is C, which is 6. Why? Because after line number 4, right, values has one element, which is 4. After line number 5 that you see over here, values has two elements, 4 and 5, and after line number 6, values has two elements, 4 and 6, because set, it doesn't add another element, but it does a replace. It replaces that particular element. So after line number 7, the values has only one element, which is 6, because we remove the first element, so it makes sense. So that is 6 over here. Question number 22, and if you see this question, it's a very easy question actually. What is the result of the following? And the answer in this case will be D. The result is undefined. Why? Because the code compiles fine. There is no issues in the code, but an array must be stored for binary search to perform. An array must be sorted, not stored. My bad. An array must be sorted for binary search to return a meaningful result, because sorted array you can perform binary search on, because you can calculate the mid, and then if it is present in the first half, you search the first half, and if it is present in the second half, you search the second half. That's how it works, right? So mid minus 1 and mid plus 1. So if it is not sorted, it's not going to work, and it will just return an undefined value. I hope that makes sense. Question number 23, guys. It says what is the result of the following, and list integer. So it's something like this, and we have some operations on that particular list. And in this case, the answer will be A minus 1. Why? Line 4 creates a fixed size array of size 4, right? Because if you see, we are creating using the as list method, and if you remember, this creates a fixed size list, right? Line 5 sorts it. Line 6 converts it back to an array. And then what happens is that the brackets aren't in the traditional place, but they are still legal, right? It's fine. There are no issues in the position of the brackets. Line number 7 prints the first element, so which is -1. That's it. I mean, you can write the brackets as this thing or this thing. It's fine actually. It's a common strategy to trick you that there is only one way of writing an array or declaring an array, but there are actually two or multiple ways, right? Alright, let us move on to the next question. Question number 24. What is the result of the following? And we have a array of string names equals to Tom, Dick and Harry, and then we have we convert it to a list, and then we use a set method, and then we print the first element of the particular list. And in this case the answer is compiler error on line number 7. Why is it a compiler error? That's a interesting question. Now converting an array to an array list uses arrays.asList method. It's not names.asList. You're not gonna apply the method as list on the reference variable or the object itself. You have to use it as a static method of the class arrays. So you have to do it like that, and that's why there's a compiler error on line 7. Otherwise it would have been worked out fine. Talking about question number 25. What is the result of the following statements, the group of statements? So the answer in this case will be D, which is 2, 1, -3. Why? Because after sorting, hex contains 30, 3a, 8 and ff. So it will be 30, 3a, 8 and ff, right? After sorting, right? Remember that numbers sort before letters and strings sort alphabetically, right? So this makes 30 comes before 8, and a binary search correctly finds 8 at index number 2, which is, if we say 0, 1, 2, it is found at index number 2, and 3a at index number 1. So 3a is at index number 1, that is fine. So it cannot find 4f, but notices it should be at index number 2, because if you remember the binary search method, if it doesn't find the element and if it is sorted, it actually kind of returns the index where it should have been present -1. So it cannot find 4f, but it notices that it should be at index 2. The rule when an item is found, which is I just told you that, is to negate that index, so subtract -1. So we get -2, sorry, 2, 1 and -3 as the answer. Because -3, how it came? Because the proper index of what 4f, right? 4f would have been 2, so we negate it -2 and then we do a -1 over it, so it is -3. That's why 2, 1, -3. That's the correct answer. Alright, let's move on to question number 26. And in this case the answers for question number 26 are A, B and D. A, B and D. Why? Let us discuss this. Lines 5 and 7, if you see, what it is happening is that use auto boxing to convert an integer int to an integer, because auto boxing means converting an int to an integer, right? Line number 6 does not, because value of returns an integer. So it returns an integer itself, so it is not getting auto boxed. Instead we are just supplying an integer which was expected, because this is an integer list. Line 8 does not, because null is not an int, obviously it's not an int, and what it is, the code does not compile, right? So however, when the for loop tried to unbox the null into an int, it fails and throws a null pointer exception. Because see, the thing is, null is still an integer. We can say integer x equals to null, that is fine, and we can also store the null over here. But when we try to do use a for each loop over here, and basically the null comes in and tries to store in this particular int age, it's gonna throw a null pointer exception, because we cannot store a null in a primitive type int, right? That's why these are the particular things. So the code compiles fine, the code throws a runtime exception. Exactly 2 of the statements use auto boxing. Okay, I hope that makes sense. Talking about question number 27, guys. it's a pretty simple question, even though it looks a little bit bigger. It's actually a pretty simple question, and the answer in this case is B, which is B. Now the first if statement, which one is the first if statement? This one is the first if statement, right? It is false because the variables do not point to the same object. Now the second if statement, right? The second if statement is true because array list implements equality to mean the same elements in the same order. So this works fine. So this returns true in this case. That's why the answer is B. So I hope that makes sense. So you can compare, if you want to compare two array lists, just go and compare it using the equals method instead of using reference equality, right? That's the whole point of equality, right? Because the double equals to operator is basically comparing a reference equality, and if there is a equals method in some classes, it's better to use the equals method to compare the values, right? All right, let us move on to the next question number 28. Which of the following can be inserted into the blank to create a date? It's very simple, guys. Now it just asks you what can you do to create a local date object, and if you remember all of the formats of creating a local date object, you would quickly find out that D and F are the correct solutions. Options A and B are incorrect because local date does not have a public constructor, so you cannot use the new keyword with local date. Option C is incorrect because months start counting with 1 rather than 0. It was the case with the calendar object, which was the Java 7 thing, but starting Java 8 API, date time API, we start the month from 1, which should make sense. Option E is incorrect because it uses old pre-Java 8 way of counting methods, again beginning with 0. D and F are both correct ways of specifying the desired date. So the off method, we can specify the year, the month and the date, and we can also use the enum, which is month.june. That is fine. Alright, next question number 29, guys. Pretty simple question. What is the output of the following code? And the answer is pretty simple. It is D, that the code doesn't compile. Why? A local date does not have a time element, guys. Remember that. If you want to work with a time and date, you have to use the local date time. So it makes sense that the code doesn't compile in this case. Okay, so that's why the plus hours is not going to work, because it's a time temporal type method. Question number 30. What is the output of the following code? And in this case it is F, a runtime exception is thrown. Why? Java throws an exception if invalid date values are passed. Invalid date values. What are invalid date values? So basically, if you see, we are passing a 40, which is an invalid date value. In this case, a month can have 40 days. Is it true? No, right? So an exception is thrown. Question number 31. What is the output of the following code? In this case, if you see, the output is B in this case. Why? The date starts out as April 30, 2018. That is the same thing that is happening over here. Since dates are immutable and the plus methods have their return values ignored because they are immutable, so if you wanna make this thing work, we have to do date equals to and then this one, because it's immutable, right? It will return a new instance of local date. So whatever. And the result is unchanged. Therefore, option B is correct. So it's the same thing. 30th April 2018. Question number 32, guys. Very easy. What is the output of the following code? And in this case, it will be E, which is 11:22 AM. Now, even though D has both date and time, the formatter only outputs time. Why? Because we are using the off localized time method and we are using the format style short. And if you remember, the off localized time will only process the time. It will not process the date components even if it is present. Question number 33. Period does not allow chaining over here. I have told that over and over again. If you see a period over here, if you wanna do this, you have to use the off method, like period dot off sorry, let me just go back. Off, and then you can pass 1, 0, 2 or something like that to do everything at once. But you cannot do this off days and off years. If you do this, only the last one will get executed and it will be the off years. So whatever, it doesn't allow chaining. That's the main thing. That is why the answer in this case is gonna be B. Okay, so only 2 years are subtracted in this case. The days aren't subtracted, because I've told you, right, because the off years is only going to get executed, the off days is not going to get executed because it doesn't support chaining like this. Yeah, so that's all about this chapter, guys, and this was some of the questions that we did for this particular chapter. And from the next video we are gonna start with chapter number 4, which is methods and encapsulation. And in that particular chapter, we're going to learn about what encapsulation is, what methods are, what is access modifiers, what are overloading methods, what are constructors, what is encapsulating data, and also we're going to learn about functional interfaces and simple lambda functions. So yeah, that's it from my side for this particular lecture, guys. I hope you liked it and have a nice day. Bye bye.